everyone, welcome back to Ascendus Blooms. So exercise 8.3, the most challenging exercise. Fourth question, first two bits. That is, first bit cosec theta minus cot theta whole square is equal to, prove that 1 minus cos theta by 1 plus cos theta. Yeah. And the second bit is cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A is equal to 2 sec A. So now this seems like really challenging, but we are going to figure it out in the possible shortest way, so that like you will, in this video you are going to find the most easiest tricks for these first two bits which you will not find anywhere else. So this is basically oversimplified, and yes, now we are going to do the first bit first, because first bit first. Alright, now see, given the question is, now given, what is given here? What is given here now? Cosec theta minus cot theta whole square is equal to 1 by cos theta by 1 plus cos theta. First thing you're going to write down is the same one, but in this expanded form. See, now I'm using a laser pointer to explain you all. If you see this, you need to expand this and write this down. How will you write that down? A minus b whole square is equal to a square plus b square minus 2ab. Alright, so that is your formula, and now you're gonna write this in the form of a minus b whole squares expanded form. Alright, what that gives you, expanded form, you're gonna write this as that. Alright, I hope you understood. Now let's write down. So that will become cosec square theta. Alright, cosec square theta, am I right? Yes. Plus cot square theta. Oh yeah, and by the way, for now you just forget about this RHS. Alright, we'll get to this somehow. Alright, so you just forget about the RHS for now, and yeah, minus 2 cosec theta cos theta. Right, there is no square now because it is 2ab. Right, cosec theta cot theta. And yeah, by the way, I forgot to tell you, how would you write down cosec square theta as? Now, first thing I want to tell you, the most important trick you need to learn is that whenever you are writing cosec square theta, don't write it down as 1 plus tan square theta. I mean, I told you to forget about the RHS, but do not forget the things which you have in RHS, that is cos theta. So basically, if this is in cos theta, that means that somehow you need to convert this into cos and sine indirectly. Now tan theta won't help you, maybe it will, but it would become, too big. The procedure would become too big, I would say. So I suggest you just make it as what? And yeah, even if you make it as 1 plus tan square theta, then this would become a mess for you. Alright, so now what are we going to write it down then as? 1 by sine square theta. Obviously 1 by sine square theta. Now, oh, by the way, just don't mind about my handwriting. Then cot square theta. Cot square theta is cos square theta by sine square theta, right? Right, and now minus 2 cosec theta cot theta. What do we know cosec theta as? 1 by sine theta. And then what do you know cot theta as? Cos by sine theta. Then what will be 1 by sine multiplied by cos by sine? That would be into cos by sine square theta. Right? And by the way, you don't forget thetas. Alright, now see here, if you observe, here there is sine square theta, here there is sine square theta, here there is sine square theta. So this is a common denominator for these three, right? So you're gonna write it down just as you know, just simple. Alright, 1 plus cos square theta minus 2 cos theta by sine square theta. Now you know that this looks a bit confusing, right? This may look a bit confusing, but don't worry, we are going to figure it we are going to figure it down like really easily. Now, one more thing you're going to keep in mind. You know what is sine square theta, alright? You know what is sine square theta? It is 1 minus cos square theta. One more thing, if you observe carefully, you will notice that this is in the form of a square plus b square minus, a square plus b square minus 2ab. This is in that form. That means here a is 1, b is cos theta, alright, and then minus 2ab is obviously this multiplied with this. That's alright? Yeah. Now what will you write it down as this? A minus b whole square. A minus b whole square is equal to a square plus b square minus 2ab. So what is a minus b whole square then? 1 square minus cos square. 1 square is 1. So you could write that down as 1 minus, no, we'll keep that same, okay, 1 minus cos whole square, because it is a minus b whole square, so it is 1 minus cos whole square only. And now what will you write down sine square theta as? You will write down sine square theta as what? 1 minus cos square theta, obviously 1 minus cos square theta. Now what are you going to write down this as? 1 minus cos square theta whole square is 1 minus cos theta into 1 minus cos theta, right? And here in the denominator it is of the form a minus b into a plus b, right? I'm going to write this down, just expand it for you or for your understanding, but that is not really required, all right? So this will become 1 minus cos theta into, oh, just don't mind, here in this part I did not keep theta, alright, but in the exam value, right, you must remember to write that down as 1 minus cos theta, alright, divided by, okay, a big division symbol. Now 1 minus cos square theta, 1 minus cos square theta can be also written as 1 square minus cos square theta, right? This can be written as 1 square minus cos square theta. Can I write that down as like that? Because 1 square is 1. So doesn't matter if there is 1 square, 1 cube, 1 to the power 4. Doesn't matter. So I can write that down as 1 square minus cos square theta. That means a square minus b square is equal to a plus b and a minus b. Right? So what will this become then? Simple. 1 minus cos theta and 1 plus cos theta. Alright. 1 minus cos theta and then 1 plus cos theta. Well, now simple, you know that you need to cancel this. Very nice strike. And there you go, you get 1 minus cos theta. Okay, there is no place I guess here, so I'll write it down here. It's congested, right? But yeah, you know, 1 minus cos theta. I hope you really understand this. Even if you don't understand, please drop your doubts in the comments, and you know, you can rewind the video and hear to it once again, and I hope this will be clear for you all. And that's our answer. So we just finished this off masterpiece. Like, of course this question needs a bit of logical thinking, but let me clear this off for you all with using small tricks. First thing, whenever you see squares on LHS, remember you need to expand it. That's the first most important thing. Just expand it off. You can see the rest later, because whenever it is given one square term on LHS and nothing else, that just means that you need to expand this. Well, some cases, in like totally exceptional cases, it might not work, but mostly 99% when there is only one squared term on LHS and nothing else, basically you need to expand it and then look at RHS once. Remember, if it's in tans, maybe you should do with another procedure. We didn't do that, but yeah, it's in cos, so we converted into sine and cos terms. Alright, and now this part, see, this part also you're gonna convert it and multiply and then write it down. So basically converting everything into sine and cos, nothing else. So we till here, there I hope there is no confusion, because it's just simple splitting and simple, LCM taking. There is no need of LCM in this question also. Well then, here comes the most trickiest part where all students trip. See, 1 plus cos square theta minus 2 cos theta, they keep it like that, and here they immediately split it as 1 minus, see, they split it as 1 minus cos square theta. Now they will see this should come here and this should come here and this should not be there. So students really get confused very much. But here comes the trickiest part. This can be written as a square minus b square plus 2ab. Don't forget to mention the identity you have used in your board exams or in your PT exams. That makes your presentation look really neat and you'll get full marks for that. Alright. So yeah, in this way we have successfully completed our first bit of our fourth identity question. And again, oh my god, I'm sorry, I think there is some technical issue. I think there is some technical error. Excuse me, just 1 minute. So yeah, we are gonna do the second question. We'll just discuss the second question first, and then we'll move on to our most important wala thing, that is second question. As I have told you, second question is very, very, very much simpler than your given first question, because the thing is, you don't need to use much of any kind of identities in this type of thing. Alright, so the thing is, question given cos a by 1 plus sin a plus 1 plus sin a by cos a equal to 2 sec a. Alright, so just forget about all that mess which has been created here. Just get that out from your mind, looking that question as a very big demon. Well, so we are gonna the second thing I want to tell you, because the first bit is over. Whenever you find two different LCM and there is like one equation on the, not equation, I mean one expression on the LHS, then that just means that you're gonna first try as LCM as your main weapon. You know why I'm using the word weapon? Because see, when there is only like, here this is just one expression, right? There are two different terms, but if it's something like this multiplied with something that, then you need to be thinking a little bit. But this is very simple expression, so you just first try taking LCM. All right, in most cases I'm sure that does work, and if it is not the case, then in some cases, like, it must be that the numerators are same. In such a case, you're going to take the numerator common, but in this case the numerators are different, denominators are different. That's all. So you just take the LCM. So now, what is 1 plus sine a multiplied with cos a, and the same you're going to multiply in the numerator, so that becomes cos square a, all right, by cos a into 1 plus sine a. All right. Oh, I'm sorry. Plus, so this you're gonna multiply with this, so then obviously you're gonna multiply 1 plus sine a with 1 plus sine a. That would be 1 plus sine a whole square. Keep in mind, it is not just square, it is whole square, by obviously cos a into 1 plus sine a. I hope you just understood this LCM taking method, because you have learned this from like very small classes, so I just kept that part of taking LCM. I hope it is clear. Even if you have any doubt, you drop me in the comment and I'll explain you that. Well, now you can at least take the denominator common, right? Not common, I mean, of course, just common way of writing. Alright, 1 plus sine a whole square by cos a into 1 plus sine A. That's all right. That's all that's given, right? Now, what will you write down? Okay, just tell me what is your next step. You just try to guess it, right? See, you just think about cos square A. Cos square A, cos square A. That's like really common. 1 plus sine square A, 1 plus sine A. Even that is looking all right. That is looking very fine. There is nothing to be cancelled out, right? Anything else you will find, you just tell me. You just drop that to me in the comments. Anything you have found? See, because cos square A, you can keep that as same because you can't change that, right? And 1 plus sine A whole square. Would you like to change this into something? Or in the bottom you can see cos A into 1 plus sine A. Now, is there any way you can change cos A into sine A? Or this into this? Any ways you're gonna find? Or else you can just expand this, obviously. That's the most ideal way, right? It's the most ideal way. So what you're gonna do is you're gonna split that up, okay? Because that is the only way you're gonna find out what's going on. Plus a square plus b square plus 2ab. That's all, right? That's all. But don't remember to keep this. Oh, I'm sorry. But don't remember to keep this. That is bar. I mean, that's common, but yeah. We often tend to forget everything when we are solving trigonometric questions, right? But yeah. And then here comes the most interesting part. You know, one of your identities says cos square A plus sine square A. I mean, to be clear, sine square A plus cos square A, one and the same, equal to 1. And if you see here, 1 square is 1. So basically this is 1 and this is 1. So 1 plus 1 equal to 2. Right? I hope this is totally clear. Alright, or else I'll just write another step for you all. 1 plus 1. Where did this 1 come from? 1 square is 1, so I just wrote down as 1, and cos square A plus sine square A is 1. Right? Plus 2 sine A by cos A by 1 plus sine A. You must be wondering why I am keeping the denominator the same. I could just multiply. Why I am not doing that? Of course, you will understand that in the next step, hopefully. See, this can be written as 1 plus 1, 2 plus 2 sine A, obviously. By cos A into 1 plus sine A. That's all right. Of course, I think you all got my point. Now what you're gonna do, take 2 common in the numerator. That's quite simple. 2 1s are 2 plus sine A, that is 2 sine A. So you're just taking 2 common in the numerator, nothing else. Now why? Here comes the magical part and our most favorite part. Actually, my favorite part, I should say, because cancelling is my most favorite part, I should say, because it's just like, all you completed everything and you're just striking it off. Cancelling, that's like really cool. Now this gets cancelled and this gets cancelled. 1 plus sine A divided by 1 plus sine A. Then you'll get 2 by cos A. Even like most students confuse, even here, no need to confuse. You end up somewhere else. They ask it to end you up somewhere else. I mean they asked you to get 2 sec A and you got 2 by cos A. Now you tell me one thing. What is 1 by cos A? 1 by cos A is equal to sec A. And if it is 2 by cos A, then what? Obviously 2 sec A, because the numerator is 2. That's it. So 2 by cos A is nothing but 2 second A, and that is our RHS, right? So finally we can say the most again favorite part, writing hence proved, right? All time favorite, LHS equal to RHS, and hence proved. That's cool, right? Hence proved. And therefore we successfully completed the second bit of this masterous, disastrous, and interesting trigonometric exercise 8.34 question. First two bits we have completed, and I will meet you all in my next video with the next two bits, that is third and fourth bits. Until then, stay tuned, keep watching my videos, and I hope you really all like my video, and I also really hope that you find my video helpful. So please don't forget to like my channel. Bye bye.